Welcome all to the analog lecture series. So in this session, let us look into the next question. So one of the most beautiful question. If you observe the question, as usual, given it is common emitter configuration because emitter is connected with the ground. Okay, sir. And they have given some other data also. The value of RC equal to 2 kilo ohm and the value of base resistance that is equal to 1.4 kilo ohm, whereas the value of emitter resistance that is 10 ohm, and collector current also given, that is 1 milliampere. DC current is given, beta value is given, thermal voltage is given, base spreading resistance, it means that is RBB. RBB means while doing AC analysis, just in series with the base resistor you can connect this. You know how to draw the equivalent circuit of the transistor, right? After drawing the equivalent circuit of the transistor, go to the base terminal of the connector transistor and connect this base resistor. That is nothing but base spreading resistor. It will be available in AC. Actually, we will be talking about that internal capacitor property. There will be some capacitor. In that capacitor, we will be observing some internal resistor drop at all. That's resistor only we are considering here. So that will be base spreading resistor, means that will be connected in series with the equivalent circuit of the transistor, where we have to connect in base terminal. That's all. Okay, fine, sir. Now we have to calculate the value of voltage gain. Let us start exploring. As usual, directly draw the AC circuit. While drawing the equivalent circuit of the AC, if any capacitor will be given, we have to short circuit. If DC voltage is given, we have to short circuit. Then observe, see there, we are measuring the voltage between these two terminals, this terminal and ground. In the same terminal, see that this terminal and this terminal both are same only. If you observe, collector resistance RC also connected between this terminal and ground only. If I am calling this terminal is A, between A and ground we have a resistor RC, between same terminal A and ground we have voltage V0. So V0 is nothing but the voltage that we are measuring across RC only. And you know how to draw the equivalent circuit of the transistor. Let me go with the RE model once again in order to let you all to understand this circuit easily. Take the AC supply from the input side, then it is connected with the base resistor. Then they have also given one more resistor, that is base spreading resistance, that is RBB. I told you to connect it in series. After that, replace the transistor by its equivalent circuit. This is base terminal. In the base terminal we are having beta RE. Then this is emitter terminal. Then this is going to be your collector terminal. In collector we are having a current beta times of IB, and then we have also observed that collector is connected with the collector resistor RC. Across that resistor only we are going to measure the value of output voltage V0. Just now we saw that. Go back, just check this. This is collector resistance RC. That is what I did. And now take the emitter terminal. Emitter terminal is connected with a resistor RE. So let me connect that resistor here, RE. That's all. This is over. Now it's time to substitute all the values. Let us explore all the values because already all data is given. It's only the thing is we have to write down. Base resistor is 1.4 kilo ohm. This is 1.4 kilo ohm. RBB is given as 100 ohm. 100 ohm will be equal to 0.1 kilo ohm. I am writing everything in kilo. And beta times of RE is not known, whereas the value of RE is given. What is the value of RE? That is also 100. 100 means 0.1 kilo ohm only. Okay, sir. What is the value of RC? RC is given as, where is RC? 2 kilo ohm, right? Whereas the value of RC is given as 2 kilo ohm. You can directly substitute. I am just simply writing 2K. And we know from here collector current IC is going, we have to calculate the value of two things. One is voltage gain, another one is input resistor. Okay, sir. First, write down the relation for output voltage. The output current is going in this way, current entering point plus leaving point is minus, whereas the polarity of output voltage is opposite to the current polarity. From this I can say the relation output voltage V0 can be written as minus of collector current IC into 2 kilo ohm resistor. Kilo means 10 power 3. Treat this one is your equation number 1. Now go to input port. See there, here current beta times of IB is coming. Beta times of IB is coming. Whereas from here this is base terminal. Then what is the current that is going? Base current. Current entering point plus leaving point is minus. Same base current is coming here. Now if you apply KCL, Kirchhoff current law at this junction, what is the current that you will be getting? The current that we will be getting is beta times of IB is coming from collector terminal, base current IB is going from base terminal, that is going to be your overall emitter current. You also know that emitter current can be directly written in terms of base current 1 plus beta times of IB. That is the current that is entering into 0.1 kilo ohm resistor. Current entering point plus leaving point is minus. Now voltage drop across the 0.1 kilo ohm resistor can be written as current flow through the resistor is 1 plus beta times of IB into the value of resistance is 0.1 into 10 power 3. That's all. Now it's time to apply KVL for the input equation in order to obtain the voltage gain. Anyway, this will be plus minus, we know that is input voltage. Current will be delivered like this. Current entering point plus leaving point is minus for the resistor. Entering point is plus, leaving point is minus. It is better. See, we haven't calculated the value of beta into RES yet. How will you calculate that? I think beta is already given. Let us explore it. Beta into, how will you write down the value of RE? That can be written as VT by collector current IC or emitter current IE. Both are approximately equal. What is the value of beta? I hope everything is given, right? Beta is 100, VT is 25 millivolt, collector current IC is 1 milliampere. Substitute all the values. Sir, this is 100, this is 25 millivolt, milli means 10 power minus 3, collector current is 1 milliampere, 10 power minus 3, it will get cancelled out. Further I can write 25 into 100 will become 20, that is 2500, or I would like to write this one also in kilo ohm. So 2.5 kilo ohm, that is the value of overall beta into RE. So we have explored the value of beta into RE also. Let me remove it by its equivalent value 2.5 K. Now we can easily apply the KVL for the input equation, but while applying KVL we can add all this resistor value. 1.4 plus 0.1 will give you 1.5 plus 2.5, totally overall will become 4 kilo ohm. Yes or no? So 4 kilo ohm into current, the entire current, the overall current is IB only. So the total resistance here it is 4 kilo ohm into base current IB, whereas current entering point plus leaving point is minus. Now if I will apply KVL in this way, what I will be getting? You will be starting from minus input voltage Vn plus overall base resistance is 4K into the value of base current. I have added all the available resistors in the base terminal. Then we have to cross the emitter. Current entering point plus leaving point is minus for your emitter. So entering point I have taken polarity already. Voltage drop can be written as current flow through the emitter can be written as 1 plus beta times of base current IB into 0.1 into 10 power 3, or 10 power 3 means kilo, equal to 0. Now from this you can easily write down the expression for Vn. Vn can be further written as, sir, we know the value of 1 plus beta. See, beta equal to 100. Remember one thing, when beta is very large, then 1 plus beta is approximately equal to beta only. See, 100 plus 1, 101. 101 is almost equal to 100 only. So what I can say, I can replace this overall value by 100. 100 into 0.1 will give you 10. Yes or no? Yes, sir. So here we are having 10K into IB. Here we are having 4K into IB. So overall value will become 14K into IB. And see there, here I am having minus. When you are passing this whole 14K into IB to the right hand side, one more minus will come, minus will get cancelled. So totally it will become equation number 2. What is the equation number 1? Output voltage. Already we got this. Yes, sir. V0 equal to minus IC into 2K. Now let us bring the relation between these two people. We know V out can be what we got, minus IC into 2K. 2K means 10 power 3. This can be further written as minus IC can be replaced by beta times of IB into 2 into 10 power 3. Just I am trying to bring the relation between input and output voltage in order to obtain the voltage gain. So the value of voltage gain V0 by Vn will be equal to minus of beta value is 100, you all know. Base current IB I don't know, but I am going to cancel it. So 2 into 10 power 3 upon, in the denominator, just 14K. K means 10 power 3 into base current IB. Yes or no? That's all. So 10 power 3 will get cancelled. Base current will get cancelled out. Finally, we can cancel this one also. That is 7 times of 2 will be 14. Yes or no? I hope you all getting it. So this will be equal to further minus 100 by 7, or you can also reduce it. Let us reduce this. If I will be cancelling this value, what you will be getting? It will become 1 times of 7 will be 7, remainder will be 3. 4 times, so this will become again 1.8. So that is the value of voltage gain. So successfully we got the voltage gain for the given common emitter configuration minus 14.18. That's all. So what is the next task? Now it's time to explore the value of input resistor. See, I have already given the clue how to calculate the value of input resistance. Can you please do it? Yes, it is very easy. Input resistance means we have to bring the relation between input current and input voltage. See there, I have already derived the expression. This is the input voltage and input current expression. There is no point of doing this question one more time. If you are having common sense, base current is nothing but our input current, whereas input resistance will be simply defined as the ratio between input voltage and input current only. So if you pass this IB to the left hand side, Vn by In equal to 14 times of K, that is 14K. So the correct answer is, for the input resistor, the answer is 14 kilo ohm. Input resistor can be written as 14 kilo ohm. And let me tell you one more thing. Actually here we did the approximation. Do you remember? In place of 1 plus beta, I have been replaced beta. If you are considering that 1, then what will happen? In place of 1 plus beta means you will be getting 101. So that 0.1 factor also will give you exact value of input resistance will become 14.1 kilo ohm if you are considering that effect. You can just substitute and cross check here. In place of 1 plus beta, just substitute 101. Again, if you multiply it by 0.1, it will become 10.1. Instead of considering 10, it will become 10.1. So overall 10.1 plus 4 will become 14.1. That's also the answer will become 14.1 kilo ohm. So we got the answer for both of these questions. I hope you all understood how to solve this question. See there, till now I have been solved only some 3 to 4 questions. But you all got the idea or not? Yes. If you don't get the idea, my sincere suggestion, one more time watch the lecture from the first beginning. At maximum half an hour to 45 minutes it will take. That's all. It will help you to get 2 to 4 marks in your examination, any examination. Okay, so this is all for this lecture. Remaining things you will see in the next class. One more small suggestion: if you are really understanding whatever the content that I am delivering, don't forget to click that like button, and also please share it with all your friends. So thanks for watching our videos. Thank you all.